Hello, welcome to the Writing Engineer. You'll notice that the perspective is a little bit different today. I'm going to be doing something a little different, so I thought a change of pace would be nice. Previous posts I've done about the importance of having other things to do, other hobbies, other things that you really care about. Well, I have a pet snake, so that's one of the things that I care about. And so today, we're going to be making a 2-zone heating control unit for my snake. So the first things that we're going to need are, there's kind of a lot of stuff and equipment that's going to be going with this. Most of this people should have around the house, I believe. And the stuff that you can buy online, I will make sure to list in the description box below when I'm done. But here's the stuff that you're going to need to start. First thing, fine point Sharpie. You're going to need a screwdriver, ideally one of the ones that you can detach and will have both a flat and a Phillips head on it, a Dremel or Black & Decker rotary tool. You can also use a reciprocating tool if you want, if you have one of those. You want a cutoff head with either heavy duty or standard blades. Some razor blades wouldn't be amiss. You'll definitely want some wire cutters. You'll want some files for when we're done cutting stuff out. And possibly a hot glue gun. All right, I'll make sure I list those below so that you can gather them if you ever want to try one of these. All right, the next thing that you're going to need are going to be the components to put together this 2-zone controller. The first is an Inkbird temperature controller. This is Inkbird Industrial Automation. Should be able to see it there. Model ITC-106RH. Power AC 100 volts to 240 volts. One piece. This is an AC relay switch. Temperature controlled. You will also need a fused outlet, which comes in several pieces. You can see here it's got a standard computer interface on the back. Comes with a switch, a fuse and a fuse holder, and the cables and cords that you need to connect it to the rest of your device. You'll need you'll need 2 heating pads. For mine, I have the 6x8 heating pads because I have a standard 20-gallon tank. I apologize if things are shaking here. Thermocouples, Type K thermocouples that go with, oops, there goes the fuse, that go with the Inkbird temperature controller. These are terminal blocks, which you use for connecting electrical wires to each other. Some wire nuts, and these are things that go with the electrical box that I'm going to be using, so that the wires going in and out don't get pulled on. One of the most important things is a box. This one is an Uxel from China. I'll make sure that I put the dimensions of this below, but this is big enough, just barely, to fit 2 of these Inkbird controllers. Also, you want some rubber grommets. Again, these are also from Uxel in China, for your thermocouples and wires to go in and out. Also useful, some screws and such to secure things inside. Right, a couple of final things that you need, which I didn't show before and which I can't show now because, you know, some of them are in use, keeping my snake's cage heated. First, a pair of safety goggles is going to be a good thing to have. A tape measure or ruler with centimeters on it. This is useful for measuring things, and I find that for measuring things for fine work, using the metric system, centimeters and millimeters, is often a little bit more accurate than using inches. we're going to need several standard computer cables, at least one of which is going to have one of these types of plugs on it. Mostly you're going to be using these for controlling your outlets when you have them plugged into. You're going to need one two socket outlet, which you can ideally the kind which you can separate the outlets one from the other. And last but certainly not least, some decoration. Anything else that I've forgotten, I will of course call out while I'm doing this video. So first thing that we're going to want to do, we're going to want to take our project box here, and you want to find these two pieces that will come out, and you're going to want to find the one that has the best surface on it, because this is going to be the one that we're going to cut into and will be on display to the general public. So you take your unit, and the cover should just lift straight off like this. You see that on the inside there's these two panels, one for the back, one for the front. And inside will also be some screws to hold them together, and some feet which you can attach to the bottom of this to stand it off from the ground. I would suggest you put those on. Those are it'll just give the whole thing a nice finished look. So the first thing that we're going to want to do is, because the controllers are not infinitely small, they are tiny. They are fairly tiny, which is why we're going to be able to fit two of these in. So this is the PID controller right here, and as you can see, it is quite small. It does call out a 45 millimeter cutout for using these. That is the width of this dimension right here, 45 by 45. You can see it has a lip around the front for the front panel, which is wider than 45. So we're going to cut out 45 by 45 and sit these right in. But you'll be able to see they shouldn't go like right up to the edge here, because there's these little posts. Okay, so we're going to have to measure from the inside of this wall here to the inside of this post here, and that's how far we come in from our edge over here. Okay, probably maybe plus or minus, a millimeter or two. So we're going to need to take that measurement, and so the measurement that we're going to go with here, so we're going to call that, used a little bit finer here. Okay, so let's see, that's 10, 11. We're going to call that 12. Okay, here we go. You can see I messed up a little bit on this side. But these two lines right here, these two little tick marks, are the 13 millimeters. So I moved it in just a little more, just to be safe. And then I found that included with the Inkbird controllers are these wonderful little clamps, which you'll then put inside on them just like this, and then slide them all the way up. It's going to take a little bit of effort here until they reach these ridges, right? But fortunately, the clearance on these is exactly the clearance that you're going to need to do the square. So once we're done, that'll cut out most of it, and then we can just file down the rest so it fits perfectly. So you can see the edges are a little bit weird, but that's okay, just because these have a little bit of a bow in them, but it's fine. So we're going to go and we're going to cut these out, this square here, and then the further square over here, so that the two are spaced properly. Then we'll clean up the entire surface with some isopropyl alcohol. We don't want to use acetone on this because this is plastic, and if you do use acetone, although it will dissolve the Sharpie very well, it will also dissolve your faceplate, and we really don't want that. We want these faceplates to be pretty nice when we're done with them. Okay, so now we're back, and you can see I have the cutout for the temperature controllers, and they will fit right in. nice and snug like that. And we'll put this ring on the back here, and that'll secure it to the back of this. And we'll put these in our little container, like so. And cover on, just so you can see it before we go ahead and do the rest of the stuff. And it's going to end up looking like that. Sorry, upside down. So we're going to have two controllers, one here, for the two different zones of our snake terrarium. So the next bit that we're going to need is we're going to have to put in a space in the back panel to put our power plug, which we're going to then assemble and insert into the unit. We'll probably use these two holes here to secure it with a couple of screws into the back panel. So we want to make sure that we only cut out enough to let through the profile of this. And I'll show you how we're going to do that. So you can take the cardboard box that the Inkbird controller came in, just cut off the lid, just like this. All right, you don't even need this tab over here. Cut this off. They're nice, a nice rectangle. Now that's approximately the same size as this, but that's not why we're going to do that. So you're going to take this, which has 3 pins in it, and a definite profile here. You're going to push the pins through the cardboard, through the other side. Careful so it doesn't hurt your hands. All right, now that we've got that pushed through, we're going to trace that so that we have a cutout to put on the back. All right, we take the Sharpie. We're just going to kind of run it around the edge here. And then we'll cut this out and kind of trace it onto the back of the thing, and then just cut that out. Hopefully this will work. Cutting the squares out of the front took a little longer than I had expected, but we're saving some money. All right, so here's the pattern of the thing we need to cut out. Let's cut this part. This is straight right here, so that's easy to do. We'll cut this, and I think this one is going to be less tolerance dependent. I don't think we'll have to be as perfect with this one as we do with the front one, because the front one, we are pretty tight for space. So we wanted to make sure we got our spacing correct with this, so we have room for both of them, and then we don't hit the little posts on the side. So I don't know if you can see, but this surface looks like a better surface than this one. This one has all sorts of manufacturing defects on it and such. So we will put this pretty much kind of however we want to, but really sort of center. We just want to make sure that we're about 13 millimeters away from the edge, so that we don't run into the post. So we'll just put this kind of just like that, and then we can trace the outline onto the back. And if we go right up to the line and then take off the line with our tools, we can be assured that it will fit in, and then we'll be able to screw it into the back. Just like that. All right. I'm going to go ahead and cut this so you guys don't have to watch this. So I'm going to be cutting this out of the video anyway. But you'll see I use the my Black & Decker tool here, and some files and a couple of sanding discs and cutoff wheels. But you can do this by hand, or if you have a soldering iron with an attachment on it. So anyone who's got some fine work tools should be able to do this. All right, let's get going here. right, so it looks like we've got our back surface done pretty nicely here. Most of this junk is going to be covered up with the edge of the socket, but we'll just smooth this out so it sits nice and flat on the surface. We'll smooth this out with a file, get a little bit of the inside here, and I'll chamfer those edges a little bit. All right, you can see the inside's still a little bit rough, but that's fine. So we're not going to have too much sitting on the inside for that. All right, let's see. All right, here's our socket. Here's our back panel. Oh, perfect fit. Excellent. All right, now we'll just screw that in place and we can put the whole thing together. All right, so now we've got our socket for the back. We've got our 2 holes and cutouts for the front. We have the rest of our stuff for assembling the socket. Our internal electronics, our heating pad, switch for the actual socket and switch, and various and sundry electronic connectors. All right, so what we'll end up doing is now we're going to start assembling stuff. You'll want to pay attention to the wiring diagram for this Inkbird controller here. Most of the thermocouples that you're going to want to buy are going to be K-type thermocouples. There are several different kinds, and they all have different ranges of interest. But this one runs off of a K-type thermocouple, and we're going to be using the thermocouple drawing. Now you see here all these numbers, they correspond to, here let me take it out and show, they correspond to socket, the things on the back, all right? See 1 through 5, and then 6 through 10 with 11 and 12 in the middle. And this on here is number 1, and it says so inside this little inside this little doohickey right here. 1 through 5, 6 through 10, 11 and 12. So we're going to attach our thermocouples to numbers 3 and 4, and then the way that you want to run this is you're going to run probably one of these in a what's called a normally open configuration, and the other one in a normally closed configuration. That means that if for some reason these things, these controllers fail, if these go offline, the little relays that are inside are always in one position when they're off. So you want to make sure that if these relays fail, that one of your things, one of your temperature controllers will fail so that the heater is always on, and the other one will fail so that it's always off. That way you still have a hot side and a cold side for your reptile enclosure. Granted, the hot side might be a little hotter than your animal might like it, but I know that snakes, for one, will thermoregulate, so they can move from hot to cold and pick a spot that's nice for them. So the thermocouples I bought nice long ones. These come with a standard plug, and these are useful. You can see here it actually labels K-type thermocouple, but these are nice long ones so you can locate your. Yeah, this is really long. I'm guessing this is about it. This is 2 to 3 meters long, so that you can locate your temperature controller away from your cage if you have to. And what we'll do is we're going to remove this thing on the back here there's 3 screws here. You can unscrew those screws and get access to the terminals on the inside. Now, we'll probably see when we open this up that the wires that are inside the thermocouple wire itself are going to be different colors. Usually for the K-type thermocouple, they're yellow and red. And contrary to what you might believe, the yellow is going to be the positive and the red is going to be the negative. So let's see if we can tell which one is which. Actually, you don't even have to tell which one is which, because on the little, since I'm going to need to, I'll open up the second one. On these connectors, they should have plus and minus. Yeah, there you go. On the other side, from where the K is, if you look at this, the the minus is the wider tab, and the plus is the thinner tab. So I may have jumped the gun here and accidentally removed this before. I should have paid attention to which tab was which. But I believe, well, you know what? It actually doesn't matter. If you hook it up backwards, all that's going to happen is the temperature is going to read upside down. So if it's supposed to be, if your room temperature is like 82 degrees, it'll read like minus 82 degrees. So all you got to do at that point is just flip it around. So we're also going to need a hole in the back here for the thermocouples to go in and out. And that's what these little grommets are for, to protect the wires from rubbing against the plastic and removing the braided covering that they have here. So we're going to have this as well. This is going to be for routing the power from our socket to our thermocouple controllers. And that'll mount right inside here. You could probably get away with not using one of these, but I like these as they give it the interior a nice finished look to them. So the first thing we'll do here is we'll assemble our switch here. All right, so we're going to do it like this. All right, and it really depends on which way you want. Which way you want it. Do you want to have up be on and down be off, or do you want to just flip it upside down and have, you know, down be on and up be off? It really doesn't matter. The way that you can remember, well, the way that I was told you can remember this is these original switches, which have the zeros and ones on them. They're for binary, for 0 and 1 for the binary system. That way you know that 0 is off and 1 is on. You know, that may or may not stick in the minds of some people, but for me that seemed to be a very simple way to remember how that goes. So we'll just take this and we'll kind of snap it in here. Just 2 snaps just like that. And now if we go back to our fuse box, we put in our fuse. And the fuses are not polarized. Okay, so we don't have to be concerned about, oops, did I goof that up? Yep, I goofed that up. So that's not what we want to do here. So if you accidentally do that, that's okay. We'll just take one of our things, we'll push out the fuse just like this. The fuse actually goes down here, just like that, in this little thing. And then this little thing goes down in here like so. Snap. All right, so the fuses are not polarized. You don't have to worry about the direction or orientation that those go in. But you do have to worry about what the amperage is on these fuses. I believe that this comes with a 5 amp fuse. So you pull it out, it should list it right on the ends of this metal can here. It usually lists 5 amp. Yeah, so this is a 5 amp fuse at 250 volts. The important thing about fuses to remember is that you want a fuse that's a little bit higher than the amount of amps that you're going to use. And the voltages you want to be higher than the voltage that you are going to be using. The reason you want the amperage just slightly higher is that say you have a circuit that draws maximum of, I don't know, 4 amps. You want that circuit to blow relatively quickly when if there's a problem inside, if there's a circuit that's shorted or something like that. That's why we have the fuse in here. So if there's a problem that something cross wires itself, or there's a short inside one of the controllers, that this fuse will pop and not destroy all the electronics that we're putting inside this. All right, so I'm gonna go ahead and attach this to here, and then we'll be back with the next step. All right, so I have drilled the 2 holes for the screws and screwed it in here so it's nice and secure. I also put in one of the grommets so we can see what that looks like. And if you're going to do this, when you drill through, it's going to be a fairly large hole. This is a 1/4 inch grommet. But I started off with a 1/8, and then we moved to a 3/16 before I went up to the large drill bit here, which is a 5/16. And the reason you want to do that is if you try and go directly to the 5/16 to get this grommet in, you're going to end up binding up the drill or wrecking the plastic. So you want to increase your steps slowly so you can get a nice clean hole. And I did a little bit of research while I took a short break, so that we could so that I could make sure that I give you guys the right information. Whenever you want to, usually whenever a switch or a circuit interrupt is done on an AC circuit, it's almost always done on what's called the hot line. There's usually 3 lines in an AC circuit, as you can see here, 1, 2, 3. This center one is the ground, and then there's something called the neutral and the hot. And the neutral is kind of the 0, if you will. I know if anyone's got an electrical degree, they're going to yell at me for that. But it's best to think of the neutral as kind of like the 0, and then the hot as kind of the one that's got the voltage on it. That's not precisely the case, but for our intents and purposes, that's close enough. And what these guys for the switch want you to do is they want you to make 2 jumps here to one side of the switch, the hot and the neutral, which is fine because that's what this switch is for. But when we take it from the other side and bring it to our controllers here, and then to our heat pads, we want to make sure that we put the relay in these guys on the hot side, not on the neutral side. Okay, because the relay is just an electronically controlled switch. So we want the relay to be on the hot side, and I'll show you how we do that. All right, so on to a little bit more assembly. So we have our switch assembled here. We're going to take our ground post here, connect that, and now we've got our, it says here white and WN for white or neutral. We're going to slip this right on here. We're going to connect it to one side of our switch. Whoops, that didn't go on quite like it's supposed to. All right, so these are supposed to go right onto these little blades here. And there's one right there. And then we'll do the other one from the hot side. Put that on. We'll go over to the hot side here. Get this connected just like that. Okay, and now the other side, this is why you're going to need some excuse me, this is why you're going to need some wire cutters. So we want to make sure that we keep track of the hot side, which is going to be this. We're going to do let's see, how do I want to do this? Since we don't have normally the in an AC circuit, there's green for the ground, then there's white for the neutral, and black for the hot. But we don't have white and black. We have blue and red. So I think in this particular case, I'm going to go with red for being the hot side. Because in other, whoops, oh, I think, there we go. Okay. Yeah, in some other AC circuits, red can also be used as a hot lead. You can have 2 hot leads. All right, so now we have our switch connected. So we're going to go ahead and just remove this connector. And if you ever want to use this for something else, we can we'll cut these leads with a little bit of lead on it so that we have some lead that we can solder back together if we want to do that. So I'm just going to cut it here with about 1 inch of space left on that. So, okay, so now we have our hot lead, which we are going to strip. These are going to be pretty small. These look like 16s. So we're going to just twist that, and we're going to do the same on the neutral side here for the blue cord. Just pull that right off and then twist it so that the cords are nice and contained. Okay, so now we have to power 2 of these guys, and we have to power our 2 heaters. And all we have are 1 hot and 1 neutral. All right, so we can see on the side here, power goes to 9 and 10. And that's going to be the same for both of those. So we're going to need at least 2 pairs to power our things. And then we're going to need another set to power our sorry, my brain has given out on me a little bit here, to power our heating pads. And that's why I bought these guys right here. These are nice terminal blocks, which we'll be able to run a couple of wires. You can see here a couple of wires in there. And if we need to, we can always take a jumper from one to the next. So what we're going to do is we'll open this up just like that. Okay. And then I'm going to put the hot lead here and the neutral lead here. So we'll just open this up. Right, you can see when you unscrew it, I don't know if you can see it or not, there's a gap now where we're going to put our hot lead. So you put that in. Now you want to make sure that you don't clamp onto the red sheathing of this of your power lead here, because that's an insulator, so you won't get any sort of electricity through there if you clamp onto the insulation. I'm gonna put in the neutral. All right. Close that down. Now each of these terminal blocks, when you connect a wire on one side, it transmits it to the other side. So now we have this, so we can put inside here just like this. We're going to have to do some wire routing, but that's okay. We'll put it in here, and then we'll run our other leads to the other side here. And if we have to run a jumper terminal from one to here or to here, we can also do that. So I'm going to go and, well, you know what? We'll do some of this on camera. So we're going to grab one of the power cables that you hopefully have set aside. You know, your standard computer cables. Now, we're not going to need anything super heavy duty here. The standard computer cable, which is probably an 18 gauge or a 16 gauge, should be sufficient. I had thought that since I had a couple that were different thicknesses, that this one right here, the thicker one, would be a heavier gauge. But I noticed here it says 18 American wire gauge, and these ones here also say, if you can see that, 18 AWG American wire gauge. So they're all the same thickness of wire inside. But we're going to use this fat one as the main supply cable, just because it's going to be a little harder to work with because it's got a whole bunch of extra insulation. So we'll just take whichever is the longer of the two thinner ones, and we're going to use that one. So you can see here I've got one that's longer than the other. So we're going to take the longer one. All right, and we're just going to snip off these because we don't really need these. What we need is a power cable to run from the inside, from the backs of our controllers over to our switch, or I'm sorry, over to our socket, and power our sockets. So we're just going to cut off here, and we're going to cut off here. Just toss those. Now you'll see when we cut these open, there's three lines in here: green, blue, and brown, I believe. So we're going to strip a little of that back so we can see what's going on the inside here. Just pull that right off. And here's a little bit of structural wire to keep it. And so now you can see we have three wires for the AC circuit here. All right. Now, what we're going to need is we're going to need some for hot, we're going to need some for neutral, and we're going to need some to go back and forth between different things. So I will show you guys a diagram of how we're going to do this, and then we're going to go ahead and follow the diagram. All right, so here's the diagram I've kind of worked out. We've got our red for hot coming in, we have our green and blue for neutral going out. So we're going to run some, we're going to run a wire from the hot side to the hot side, or to one of the terminals, 9 or 10 on each of the controllers, and then we're going to split it from there to the common on each of the controllers. And then from the common, it goes to, on one side it goes to the normally open, and the other one goes to the normally closed, and then those lines will come over here to the terminals over here. The neutrals will be connected to the other side, to B, and to the opposite terminal here. And then the grounds will be all connected to the ground, just in case if at some point in the future you have a three-prong thing that you want to run. And I'm actually going to do this up in PowerPoint, as this is a little confusing, and we'll make it a little bit more understandable. And I'll throw that up kind of right now. All right, so that's what we're going to do. And so now we can take our cable that we've stripped, and we're going to use that as the kind of sacrificial cable for some of this stuff, and we'll see what we can run, see how well this is going to work on the inside of our thing here. All right, so we know that we're going to need 1, 2, 3, 4. We're going to need several different ways of connecting the hot leads here. So let's see if this stuff will all come out. It looks like it will not. I'll have to really pull that. All right, so what I may do is pause here and go get some different type of wiring for this to see if this is going to be, to see if this is a little easier, because I think things will get a little tight in here if we have to use this size cable on the inside of this. So I'm going to see what I've got, and then we'll come back to it. All right, so I found it was just going to be easier for me to cut back a bunch of the wire and just strip off the cables that I needed. It actually wasn't that hard. And so what we got here is this is going to be our power lead for one of the controllers. One side right here is going to go into the terminal block that we purchased specifically for this reason. And the other side is going to go into a couple of the terminals on the back of our temperature controller. So one of them is going to go into right here. We see pin 10 for AC power in. So we're going to do that one, and then we're going to go for this one. This one is going to be done in a normally open configuration, so that when the temperature senses that it's too low, it switches to the closed position. It switches from normally open to closed, and then it powers our heat pad. So we're going to unscrew terminal 10 here, and you can see I had 2 pieces of wire that I stripped, and then I've twisted together here. I'm going to put those 2 ends into terminal 10. We're going to screw that down and closed, nice and tight. All right. I'm going to take the other pin. We're going to go into the we're going to use pins 7 and 8 here, because 7 is we're going to do the normally, well, let me think now, because we don't want pin 6 to be powered when the relay is in the off position. So we're going to put this into the normally open pin 8 here. And if you're following along on the guide, which I'm going to put up right here for a second, you'll see that pin 8 is normally open, so that unless pin 7, when it switches and it senses that it's the temperature is too cold, it's going to close from pin 7 to pin 8. So now we're going to use the one that says COM for common to run from there out to our outlet box. So here you see I have the wires hooked up to the back of this from pin 10 to pin 8, and then from here it's going to run over to our terminal block right here, to the red one. I don't know if you can see that. We're going to run it right here to the terminal block and connect it to the one that's red. All right. We're going to do the same thing for the other one, except in this case, we're going to wire to the normally closed position, so that when the relay is off, it just runs the heater, so that it heats up kind of no matter what we're doing. But I'm not going to run that right now, because that particular one is currently running my snake's terrarium. So we're going to wait on that for just a little bit. I am, however, going to connect these 2 wires that are going to connect from the terminal block to the back of the unit to provide both power to the unit and to the heating pad. So what I did is I stripped the 2 ends here, place them next to each other, and it really doesn't matter in which direction that you twist them. unless you're using a wire nut, in which case it does matter the direction that you twist them. But since we're going to be putting this directly into the back of our Inkbird control unit, we don't want to do that. We're going to strip off the other end here, and then twist that so it stays nice and tight. And then we're going to do this end right here, strip off that, and twist it so it stays nice and tight. So this end, this single end from the long wire, is going to run over to our terminal block. And then this end is going to go into our pin 10, and this end is going to go into our pin 6 or 7. It doesn't actually matter which. So I'm going to hook these two wires up together. These are the two power feeds to our temperature control units. And now we'll run those underneath our wires here to the terminal block, to the other side of the red, which is the one that we decided we were going to put as our hot lead, because sometimes in AC circuits there is a red hot lead. White is always neutral, so I picked the red so we won't get confused in the future about which ones go where. So we'll connect that together just like this. Now I am not going to secure this terminal block in at this point because I'm going to put this whole thing together and then check to make sure that it works before I secure everything in its proper place. Because once I secure everything in its proper place, it's going to be very difficult to move anything around or to get things into a place where we want to have them. All right, so now we got to run the neutral lines, and the neutral lines are going to run from the blue here. So we're also going to use the blue wire which came in. That's partially why I chose the brown wire to go to the hot side. So this blue wire we're going to cut so it fits. So it goes from our neutral terminals here, the blue one, to our other pin on each one of the control units. In this case, it's going to be pin 9. So we're going to have one that runs from here to this pin 9, and one that runs from here to this other pin 9. We'll probably do the same type of thing here, and go from here to here to here, so that they're all on the same neutral. And then what we can do is we can run the last wire from this out the back of our box to our outlet box, and I'll show you what that looks like in just a moment. So first thing we want to do is we want to cut a decent length so that it'll reach to here. That looks like about a decent length to reach to the first one. So we'll just cut this right here, snip. And then since we're only going to be doing a jumper from here to here, we can cut another length about this long for our second one. I'm going to strip all ends of these wires. I would suggest somewhere between 1/4 and 1/2 inch strip for each one of these. Unfortunately, I'm doing these with a tool set that's not exactly perfect for this. This is really designed more for heavy duty AC stuff like house wiring and whatnot, not instrument wiring, which typically requires smaller gauge wire. So these are all 18 gauge wires. In case you don't know how wire gauges work, the larger the number for the wire gauge, the smaller the wire. So typical house circuits will run on either a 14 or 12 gauge wire, unless you're doing something really beefy. You might go down to a 10. But a lot of computer equipment and stuff like that runs on 16 or 18 gauge. You may get the occasional 14, but that's a little doubtful. So we're going to run this neutral per our diagram from our neutral here to pin 9 on this bad boy, and then we're going to run the other side to pin 9 on the other temperature controller. Then we'll start worrying about where we go with the relay switches. All right, so here we have the controller, and I've threaded one of the temperature probes, the thermocouples, in through the back. So now we're going to take one of these wires, which I have the positive lead is here and the negative lead is coming out the top, and we're just going to connect it using the diagram, which says that if we're using a thermocouple, the negative side goes to pin 3 The positive side goes to pin 4. So we're going to connect that, and then we'll have this particular one connected up to its sensor, and we'll have it connected up to the power. And then all we'll have to do is run another power cable from the back of this unit to our socket to power our heater. And then we'll be pretty much ready to go to disassemble Doodle's other heating unit and put it in here, doing the exact same thing. So now these wires look really thin, but they're pretty stiff, so you don't have to be too concerned with accidentally tearing them off. And once they're in place, unless you start yanking on things, or have really small children, everything should be fine. So the last thing that we're going to do is we're going to hook up. We have our hot lead hooked up to pin 8 on the normally closed side. On the normally open side. And then we need another positive. We need another lead to go from here out to the socket, and then back onto the neutral line, thus completing the circuit. So I'm going to go get the cable for this, and then we can start hooking that up. All right. So I've taken the last bit of the cable that I had, stripped off a good 3-4 inches. It's okay to have them a little bit longer. You can always shove them in there, but strip off a nice good long length. And what we're going to do is we're going to put it in to this box. Now, if we just leave it in there, we're going to need space for 2. One to run each of the sockets that we're going to plug our heating pads into. We're going to need 2 wires this size. And really the only way to clamp these into the unit itself. This is one more thing that I forgot to add. These are really cheap. I think I bought 2 of these for like $1 at the local hardware store. And what these are little cable clamps. I'll get the exact name for them. But these are clamps that go into electrical boxes that would normally go into your wall. And these screw in your electrical cables go in through this side where the screws are, and then they come out through this side. And these screw into your box. Oops. All right, so I'm not sure how much came out on that, but what we've done is I drilled a hole in the back here. I have put a junction box clamp. This is for internal house wiring. So this is rated up to 20 amp service at 120 volts. We're not going to be using that much, but it is for 120 volts. So I've got a hole that goes through the box here. Put this in, and it's got a nice little washer nut that goes on the back. It just screws on, just like this. So last time it went on very easily, and when I had to redo this, it's giving me a little bit of a hard time right now. But this screws on to this unit right here. That's okay. Come on. What the heck? All right, goes on fine. So I'm just doing something wrong on the inside of this thing here, probably cross-threading it. But that's okay. So what we do is we screw this on, and then we put our wires in. There we go, finally, good grief. We put our wire in. After I'm going to strip a little bit more off of this. We're going to put our wire in through this for both sockets. And then this is going to get clamped down so that the wires will be nice and secure. They'll have a nice strain relief, and we won't be able to pull out the internal electronics. So I'm going to go ahead. I'll strip off a little bit more of this. I'll get the other wire set as well. We'll put these in and hook them up, and then we should be ready to take apart Doodle's enclosure heater and put the other unit in here, hook it all up, and get the plug ready to go. Quick thing before we go too much further in this. As everybody can recognize in the United States, this is an outlet. Specifically, this is a 20 amp outlet. You can tell by the extra little slot that it has on the side. Some 20 amp circuits and plugs will have their thing turned sideways. Now, a 15 amp one will only be the vertical ones, right? So it doesn't matter in this particular case whether you use a 15 or a 20. However, it is going to be useful to note that this round one on the bottom is the ground. The short slot is your hot side, and the long slot is your neutral side. We've got to make sure that we don't want to mix these up because we're going to be switching on the hot side. And if we accidentally put to neutral on this side, everything's going to be backwards. And it's most likely that you'll either, best case scenario, your heater won't work. Worst case scenario, stuff feeds back and catches on fire and breaks. So we don't want to do that. So just keep in mind, short side is the hot side, right? The way you can remember that easily is short and hot. Hot is a short word. Neutral is a long word. So the hot goes to the short side. Okay? Now, back to the construction. Well, due to some video failure, I lost a whole bunch of videos. But that's okay because I turned this thing on and it turns out that it didn't work because I forgot to hook up my neutral to my second controller. So we're going to do that right now. And then I'll show you, I'll turn it on so everyone can see. Now what I'm going to do is we're going to, well, first we're going to go get my stand so I don't have to hold this in my hand. All right, hold on. So here we are. So we're going to remove the wire nut that we have here. We have to add one more neutral. See, I have one end that's stripped long and one end that's stripped short. We're going to put the long one over here. We're going to twist that onto the other neutrals. And we're going to put the wire nut onto this. All right, now we're going to take the other neutral end and we're going to put it into pin 9 down the bottom here. It's going to be a little bit difficult because I have this whole thing kind of together, but you know, unfortunately, I'm going to have to take a little bit of it apart here so I can get at the screws. These screwdrivers are actually awesome. They have 2 sizes of Phillips on one side and 2 sizes of flat on the other side, and they're reversible, and you can put them in for whichever size that you need. So I would recommend everybody pick up these ones just for, even if you live in an apartment and you're not responsible for the maintenance, these things are fabulous. So we're going to actually take the whole thing out of its case so I can show you what else I had to do. And you can see here on this side we have a hot and a neutral going in, but on this side I forgot to put in the neutral. So we're going to put in the neutral wire over here on this pin number 9 right here, which we're wiring this controller the same way that we're wiring up the other controller so that everything is the same in case anybody needs to come in and do some repair on it in the future, that everything is wired the same on both sides so that no one gets confused as to what is going to go where. All right, so now we've got our second controller wired in with a thermocouple here. This controller, you can see, is wired slightly different than this controller. This one is going to be in the normally closed position so that while this unit is off, the socket will be active once this is plugged in. So it will receive power if this unit fails or for any other reason this whole unit goes down. The hot side will still stay hot, and this one is going to be normally open, which means that the switch is not going to be closed, so that this side will be normally off. All right, we're going to reassemble here. I want to show you the inside of this box. I had to do some tailoring. These pins were getting in the way of my second controller, so I cut them off. I'm going to reassemble this back together. All right, get the slots lined up. This goes in. So those little nubs that I had to cut off there were getting in the way of this second controller. And I've decided not to secure the terminal block in here at this point, just because in case I have to open this thing back up, in case something is wrong, I don't have to deal with another set of screws or removing glue. Now this is very important to make sure that all your wires are tucked out of the way from these standoffs here, because those are our standoffs for the screws that are going to hold this whole thing together. So make sure that your wires are kind of tucked down and that when you when you put the whole thing together, that it's not going to interfere with putting the cover on. I can also show you the same. I did the same on the top here. I cut off these little nubs on the inside so that when we put it together, they don't fall down on this one. All right, we put this thing on the top here. Kind of, yeah, see, we got a little bit of a wire there that's kind of getting in our way. So we'll push that in. Now the whole thing snaps closed just like that. All right, and those snapping noises is the face plates going into the grooves that are in the box. So we're going to take the little feet, which have these screws and black things. We're going to stick them in the holes. I'm going to screw the whole thing together. And I'll hold it up so you can see that even though I have never done one of these before, this is actually not going to look half bad. And I'm hoping that any of the mistakes that I've made in this video here, anyone else could rectify with a future version. I would recommend that if you're doing this and you're not confident in your skills of cutting or able to manufacture these type of things, get a box that's a little bit bigger than the one that I got. I've had some experience cutting things out and forcing things to fit in positions, but if you don't have that particular type of experience, or just want to make it easier on yourself, get a little bit bigger box. This one is a decent size, but something that's a little bit wider this way and a little bit wider this way and a little bit thicker this way would make it easier for anyone to assemble this. All right, so there's our front. Here's our back with our two cables coming out that we have wired into the box here. I'll quickly remove that since that part of the video was also lost. So what I've done to this socket here is all of these particular types of things, all these particular outlets have the ability for you as a person. I'll just wait until this is done. All right, so all of these outlets have the ability for you to control these things, each one of these sockets individually in this circuit. You can see here on this side, this is the neutral side. You can tell because there's silver screws here. It's got a little bar across the top connecting the two terminals. And the opposite side usually would have a bar, but what I've done is I've removed it so that each of the hot sides that are connected to the relay terminals inside of our thing controls one of these sockets. All right. So I remember my brown one was my hot side for the snake cage, and the black one was the cool side. So I've put a little H there for my reference. But we've removed the bar across here so we can control each of these sockets individually. We then put them through it's a little strain relief thing that you can put inside this little project box here, which you can get at Home Depot or wherever. And I've shoved these in so that the black portions of the cable here are contacted by the strain relief. So if you get little fingers pulling on this thing, they're not going to be pulling directly on your wire connections on the inside, but rather on the sheathing that's connected to this box as a whole, so that it doesn't come apart if someone is accidentally going to pull on it or if it falls off the shelf. So we're going to screw this back together. Whoops. So we'll screw this back together, put it on the cover plate. Just get that one started, and we'll get this one started over here. These are extremely useful. Don't use a drill for this. As I was saying, don't use a drill for this. Drills have entirely too much torque. So you could very easily destroy the socket which you've worked so hard to assemble. So I would recommend if you have an electric screwdriver, use that, or just do it by hand. They're a little bit long screws, but it's not going to kill you. All right, we screw on the faceplate, and as you'll see here, my faceplates are rather on the large side because my house has horsehair plaster walls and not drywall walls, and they tend to crumble when you cut into them. So you can buy these larger ones to cover up any mistakes that you make when you're cutting into your walls. So you see here, this is an entirely assembled unit. We have our hot side with a little H and our cool side here, our entire assembled thing. Now what we're going to do is use our last computer cable, which we did not break or cut. I'm going to plug it in here. Remember, 0 is off, 1 is on. Here we go. Let's see if this works. Oh! Sweet. It works. All right, so let's check our 2 thermocouples here. I have very, very long thermocouples because I wanted to be able to place these wherever I wanted to place them. So we're going to grab the hot side here. See what happens. Oh, the hot side's going up. Excellent. I'm going to grab the cool side. Oh, cool side is wired backwards. Okay, so we have to go in and we have to fix that. Change the 2 wires around. So I'll do that and we'll continue on from here. Here we are back. We'll turn this on. We'll see that both of them come on. This one is in Celsius, unfortunately. The other one's in Fahrenheit. So we're going to have to run through and correct that. We want to go over to Fahrenheit so we can set it to 72 degrees. And if I'm being honest, even though I'd use Celsius all the time when I'm doing my stuff at work, Fahrenheit offers a much finer control because the degrees are, it's about half a degree per degree Celsius. So if you set it to, you can get a much finer control on your unit if you use Fahrenheit. So what we're going to do is we're going to push, let's see, it says push the set button for 3 seconds. Let's see, so we're going to push this. All right, 1, 2, 3. All right, so 1 P is set there. So what we're going to do is, okay, there was not a mouse. So what we're going to do is we're going to push this button here. It allows SN type, that is input type. So we want to change this to I believe that's supposed to be a K. So that's what we want. Calibration display units. So that's going to be setting range. And digital filtering. That's not what we want. So we push this one again. One input. Output. Set. Control. We want PID mode. All right, then we push set again. We want this on heating, not cooling. Push set again. We want it on, this one stands for run. A manual, hold on, what do we got here? The thing is manual inhibit, auto, what's this one set for? Because I know this one is set up correctly. Control, heating, cool. All right, so we're going to set these two. So those are the same. And then that goes back to OP. All right, so I think the rest of the stuff we're not going to mess with. ALTP. We don't need that. That's alarm setting. PID. We're going to just see what this one says here. We're going to set these for the same things. All right, so this is the one that I've already set that's correct. We go back to PID. And then we push set again to get to the units. This one is set for Fahrenheit. This one is set for Celsius. Now it's going to be set for Fahrenheit. Push set again. And we're done here. All right. So now we just wait for a second or two, and this should come back to normal. So this, there we go. Now they're going to come back to normal. Okay, so this setting over here should be, we want to do 72 degrees. So we'll just kind of hold this one until it says 72, because it's currently set for 50, which is a little bit cold. I don't know why this still says 20. That's not right. That should say 65 like the other one. That makes me believe that this is still in Celsius. So I'm going to fix that and then we'll come back. So we have the unit installed here. What I was noticing before is that my hot side and my cold side were not measuring the same temperature. They were off by like 2 degrees or so. So what I did is I took an insulated mug and filled it with some warm water, and I checked the temperature with a meat thermometer right near the surface. And then what I did is I took both the thermocouples and I put them just under the surface of the water and read which one matched the meat thermometer. And then I went into one of the sub-menus here, and there's a calibration that you can change. I changed it by 2 degrees, and then they ended up reading the same. Right now I have it installed in my cage. One's under here, and the other one's under here. So this is my cool side over here, and the hot side over here. And as you can see, the cool side measuring cool is on, and the hot side measuring cool is off. But that's okay. That's what we want. That means that it's running in cooling. That means the thing is going to heat up. And I'm sorry, my controller is actually on a tilt here. It's not the video. So that's it. If you have any questions or comments, please leave them below. And I apologize if that last bit was unclear, but I'll put all the specs and stuff for what I did in the notes below. Thanks a lot, and I hope you enjoyed today's video.